Hi, my name is Derek Nichols. I am the Sustainability Engagement Coordinator here at UB. I'm really excited that you're all here, especially because it's the first super nice day in Western New York, so I know you'd all rather be outside. But we're kind of celebrating all of that good stuff outside today. So inside for as quick as we can get, so we can go out and get a tan, right? We have two great things coming at you tonight. The first half of the program, UB Sustainability, will recognize our sustainability champions that are already doing great work on campus and in Western New York and actually around the globe. And then after that, we're going to take a deep dive into clean energy, and we'll hear from our future leaders that will revolutionize this industry. They will present some thought-provoking and novel ideas that will impact our energy system. So let's start off with a celebration. I'd like to bring up on stage Ryan McPherson, Chief Sustainability Officer here at UB. He'll have the honor of handing out these awards for sustainability excellence to students, to the student, faculty, staff, and departmental leadership. So here you are, Ryan.
Thanks, Derek. Thank you. All right. Well, thank you all, as Derek said, for giving up a little time with Mother Nature. We will get out there as quickly as we can. Also, we're doing something a little bit different with this event. At the end of a sustainability month with about 40 different events, and at the end of the semester with all of the events going on, sometimes we find it a little bit challenging to get everyone to the event that we want people to come to because they've got so many different opportunities. So what we're working on this year is we're actually trying to package these up in video format so that we can share them with our campus audience and with our community. So actually, as much as we all love you, you are not the primary audience tonight. The primary audience is the video camera, as we've been talking about, with our student leaders and our clean energy leaders, as well as our sustainability stars here on campus. So with that, we have 4 recipients today that are going to headline our 4th annual SLICE Awards, and that stands for Sustainability Through Leadership, Innovation, and Collaboration. I still have to actually look at it every time. And our 4 recipients are being recognized for their personal and organizational leadership and the way that they've helped the university become all that it can be in terms of our sustainability objectives and work. Their creativity and innovation really, I think, inspires the rest of us to find new ways to personally contribute to a more sustainable triple bottom line as we think about how we treat our people here at the university and how we leverage all that human capital, how we steward our environmental resources, and how we think about penciling things in terms of our economic prosperity. Through their collaborative efforts, their relationships, and willingness to work together, we're reminded every day about the power of coalitions and about the power of leveraging one another to achieve our objectives. So in keeping with our practice of repurposing, if you can be our display here, of repurposing our campus, we're going way, way back tonight for these are actually bricks that were uncovered when we were siting the temporary, the exhibition mode of the Grow Home on the South Campus, and we believe they're from roughly 1893 when Erie County had its almshouse at the university before Hayes Hall was Hayes Hall. So we also had a student do some great work in terms of, I think, laser cutting, right, of some of these, as we've done the years prior where we had pieces of Davis, pieces of Hayes Hall, pieces of the new medical school, and thinking through those. So thank you very much. So without further ado, our staff award for sustainable operations will be presented by Vice President Scott Weber. Thank you, Mr. Weber.
Should I come up here? I guess.
Yes, why not? For us short people, we need to come up here, but you may not.
Oh, no. How's that work for the microphone? Is that all right? Okay. I feel like I'm working a crowd here already. It's really nice to be here, everybody. And well, it's going to, because of the honoree today, I gotta make it sound like I'm working the crowd, right, Hadar? Okay, very good. So throughout her career, Hadar Borden has worked to advance and integrate sustainability into the fabric of university through her work at the Honors College, the undergraduate academies, and more recently, the Launchpad, the Blackstone Launchpad. From forming the Sustainability Academy to advancing social entrepreneurship through programs like Erie Hack and the World's Challenge Challenge. Hadar has created an immense impact in advancing the university's sustainability objectives. She has a unique gift in engaging students in the pursuit of new knowledge and learning opportunities. Hadar's work in exposing, engaging, and empowering students through purpose-based sustainability work has helped hundreds of students to gain new perspective on how doing well and doing good can not only coexist but thrive together. The recognition that sustainability is not a goal, but rather a strategy to apply to your existing work is fundamental to her practice and has enabled every student she works with, and I'm sure many that she never knows she's touched, to understand that integrating sustainability into their existing work is key. Please join me and the university in congratulating this year's Staff Slice awardee, Hadar Borden. Hadar?
We'll get a little grip and grin.
Okay, listen, okay.
Wait, Hadar in the middle.
Okay.
I had to be in the middle.
Okay, hold on, let me do this.
Thank you, Hadar.
Thank you.
Thank you. Great, so our Student Leadership Award for Sustainable Action will be presented by Tim Matthews, our Assistant Director at the Honors College. Tim, thank you very much.
Thank you. Well, hello. Again, my name is Tim Matthews, here from the Honors College. I've been this is kind of a proud advisor moment for me, as one of our current students is being honored today for some of her hard work, particularly on the UB Repair Fair. And that's just one of the many examples of her leadership on campus, but just the culminating effort. But she created this UB Repair Fair, organized all the events for it, put it together, and to me that's just kind of a culmination of all the things that she's done here on our campus. So we're really proud of you for all the hard work that you've done. Again, proud advisor moment for me. I think on behalf of the Honors College, and of course I think I speak for all of us here and the rest of the university. We're really proud of you. So Stephanie Aquario, come on up.
Thank you, Steph. Thank you very much. Thank you. Our Faculty Award for Sustainability in Higher Education will be presented by, this is one of the best recommendations I've ever seen, by UB student Erin Sweeney. Erin, thank you.
Good afternoon. So Dr. Samina Raja had a prior commitment at a national event today, so I'm honored to accept this award on her behalf. And I'd like to thank the UB Sustainability Office for the honor of her selection for this award. I am a graduate student in the Masters of Urban and Regional Planning program, and I'm lucky enough to work in the Food Systems Planning and Healthy Communities Lab under the guidance of Dr. Raja. Dr. Raja is an outstanding mentor, teacher, researcher, and engaged faculty member in the Department of Urban and Regional Planning. Since she arrived at UB in 2001, Samina immediately began to consider strategies to conduct meaningful, community-engaged research and simultaneously support students' learning. She began working with student researchers in 2003 and formalized the creation of the Food Systems Planning and Healthy Communities Lab, or Food Lab, a few years later. The lab's aim is to conduct research that critically examines the role of local government policy in creating equitable, healthy, and sustainable communities. The lab is focused on community-based food systems as a place for supporting transformation at the local, national, and international levels. The lab has emerged as a leader in both accountable research practices as well as a space for training and development of future scholars. Samina currently mentors and trains students at the high school, undergraduate, graduate, doctoral, and postdoctoral educational levels. Students in the lab come from a wide range of disciplines, including and outside urban planning. Due to Samina's leadership and commitment to student growth and intentional and collaborative research, UB students may explore a range of topics related to many components of the food system, from agricultural production to distribution of food to food waste management. Samina has mentored more than 50 students in her lab over time and has provided guidance, support, and research opportunities to hundreds of other students throughout her career. She also collaborates with faculty at UB on projects in Buffalo and around the world, and provides inspiration for faculty and students to engage in community-based research focused on sustainability. Through Samina's guidance, the Food Lab's research explores how to build equitable, sustainable food systems and communities through policy planning and practice. Because the food system is inherently linked to sustainability, the lab brings together students with interests in climate change, water and soil contamination, solar energy, as well as topics more tangentially but inextricably linked to sustainability, including education, homelessness, informal markets, vacant land, refugee health, and more. Through Samina's mentoring and leadership, students have gone on to pursue PhDs, work for local governments and research centers, as well as non-governmental organizations across the country and around the world. Please join me in giving Dr. Samina Raja a round of applause.
We'll do a quick photo of both of us so that Samina can have it in Washington right now where she is. So.
Whoops.
Awesome. Thank you very
Can I take one
much.
on the quick
Absolutely.
photo? Perfect.
Yeah.
One other quick thing, then I promise I'll get off the stage. So a quick pitch, students will have the opportunity to engage with Samina's work directly this May 21st to 25th through the Global Innovation Challenge, which is hosted by the Community for Global Health Equity and with support from the Food Lab. Students of all disciplines and education levels are welcome to register, and I have a flyer here, or postcard rather. I'll leave some on the table outside, so if you are a student or know students who might be interested in exploring cultivating food equity among smallholder farmers around the world and participating in an innovative research opportunity for 1 week and get to work with Dr. Raja, then please grab one of these and register to sign up. Thank you.
Thank you, Erin. And our last but certainly not least award for sustainability excellence by a department or cross-functional team, I feel like the Oscars, like assistant cinematographer, will be presented by Christine Human, Associate Dean for Accreditation and Student Affairs. Christine?
Thank you very much. So for those of you who are not familiar with the organization, the Women in STEM Cooperative, or WISC for short, was founded in 2013 with the mission to bridge the STEM gender gap through cultural inclusion and educational opportunity. It's a coalition of faculty, staff, and graduate students across the STEM fields developing programs focused on professional development. The interdisciplinary nature of WISC is its strength, and it's critical in developing innovative solutions to the world's biggest problems. It's therefore fitting that the 4th annual summit held last Thursday focused on sustainability. The summit highlighted women as agents of change, inviting leading female scholars, researchers, and practitioners who inspired, educated, and empowered the next generation of female students to incorporate sustainable solutions into their work. It was also heartwarming to see so many female high school students at the event. A testament to the strength of the organization, when the keynote speaker, SUNY Chancellor Christina Johnson, unfortunately had to cancel at the last minute, WISC didn't miss a beat, and they put together a truly informative and inspirational panel. And in fact, our previous award winner, Dr. Samina Raja, was part of that panel. As someone who has not been involved in WISC, but who has admired their work from afar, please join me in congratulating Kathleen Murphy and the entire WISC committee on this deserving recognition of the important work that they do. Kathleen? And everybody, is everybody coming up? Is everybody coming up? Yes. Yes.
we were joking at the STEM conference. The thing that I learned the most is that when you have a panel of men up waiting, or a manel, I think they were calling it, we all try to jump in to actually comment, and I was struck at the 4 or 5, or in some cases 6 or 7 women on the panels who were all deferential to their fellow participants trying to get the points in. It was really, truly collaborative to see that in full effect. So one thing just before we turn it over, there's something all these people have in common, in addition to being brilliant, dedicated, full of grit, and just truly inspirational. This year, these were pretty easy calls, and they all happen to be women. Women leading our sustainability efforts here at the university, women providing the leadership that is really kind of taking us to the next level. So we're very happy about that, and we look forward to having more come forward as our work continues. So thank you very much for your nominations. Thank you very much for your work. And now we're going to kind of switch things up to look towards our younger generations to give us a little bit of inspiration within the framework of our REV, Renewing the Energy Vision, Clean Energy work through NYSERDA and our colleagues here at the university. And Derek's going to walk us through that great opportunity with our student kind of TED Talk panelists up next. Thank you.
All right, welcome to the main event. I feel like a boxing instructor. So let's get ready to rumble, right? So I know our teams are excited to present their revolutionary ideas, but I need to get through some logistics first. Silence your phones, as always. Like, we are going to be filming all of this, and we want the students to have a really polished video for their resume. And it would really suck if your ringtone was playing through that. So silence that, and they don't need more distractions. So the rules of this contest: for the next hour, you'll hear from 5 different teams that have ideas that will revolutionize our energy system. Each team has 7 minutes to present their work, followed by 3 minutes of question and answer from our judges. They'll be scoring each presentation based on concept, visuals, presentation, creativity, practicality, and its focus on clean energy and its potential societal impact. The prize for third place is $750, second is $1,500, and first place is $3,000. So it's high stakes, right? A special bonus prize of $200 will be awarded to the project that goes above and beyond addressing the equity and social justice implications of their idea. Before we begin, we are extending a big thank you to our partners across New York State and the New York Coalition for Sustainability and Higher Education for helping us promote this event. Not every team presenting tonight is from UB. We are excited to welcome our visitors from the Rochester Institute of Technology and Syracuse University. The night would also not be possible without support and funding through NYSERDA. The Reforming the Energy Vision is an alternate initiative through NYSERDA to engage New York State colleges and universities in implementing clean energy projects and principles on campus, in the classroom, and in surrounding communities. Currently, 40% of New York State's 200 higher ed institutions have joined the REV Campus Challenge, fostering new research and technology, implementing clean energy systems, and inspiring new champions of change like the ones you'll see tonight. I also want to thank our judges for this evening. We have Mike Forrester, who is the Assistant Director of Utility Operations here at UB. We have Antonina Samedi, who is the Executive Director of the Western New York Environmental Alliance. Eric Walker is a community solar advocate here for the region. And then Ryan McPherson is our Chief Sustainability Officer here, if you've already met. So that being said, those are the ground rules. That's the roadmap for tonight. So I want to get right into it. So our first champion here is Philip Ondecourt, and his presentation is called Making Clean Energy Smarter with Artificial Intelligence. So I'd like to call up Phil.
Thank you. Before I start, just a quick note. My font obviously did not transfer exactly the way I want it, but the good news is there isn't that much to read, so you wouldn't have to worry too much about that. With that said, I guess, let me go. Okay. There is an extraordinary revolution taking place right now. All across America, roofs with solar panels are cropping up, and electric cars are appearing in our driveways. The green energy revolution is truly here. Even more exciting is the pace at which everyone is embracing it. Today, we see solar panels showing up on roofs of the rich. We're seeing solar panels showing up on the roofs of the poor. And we're seeing solar panels show up on Toyota Corollas. The green energy revolution is redefining our energy future because in many ways, it is our future. It is cheap, it is clean, it is renewable. The perfect antidote for climate change. But like everything else, it is not perfect. The dirty side of clean energy is real. An oxymoron in all regards, it has real effects, which is affecting the world today. Now, the thing is, just last year, China alone wasted enough clean energy to power Beijing, a mega city of almost 22 million people, for a whole year. You might think this is just a mistake, but it's not. The same thing is happening in Canada. The same thing is happening in California. This is not a mistake. It's not an isolated case. It is the wasteful side of clean energy we don't get to see. So the question is why? Why are we seemingly great at harnessing clean energy, yet so terrible at using it? Well, it turns out the solar geeks in this place, in this room today, can answer that question for us. And they call it something known as solar interpretability. Now, to us regular folks, I can't even pronounce it. That just means the time the sun don't shine. You see, we still use a lot of energy even if the sun isn't shining. And to put this into context, there's a very simple story of our solar story. Basically, the yellow represents the times when we generate the most amount of solar energy. The blue or teal shows when our homes use the most amount of energy, and the overlap shows when we're using our solar energy in our homes. And as you can see, there is very little overlap. So why is that? Why is that little overlap? It turns out that, well, apparently we use most of our energy at night. And so when there's solar energy available, we can't use that. Now, I come from a family of storytellers, and my mom told me, if you don't like a story, rewrite it. This solar story of energy waste is one that is unacceptable, and we need to do something about it. So how do I do something about it? Well, I retell my story. This here shows the energy, every line here you see shows the energy use of a home in America. In all, there are about 1,000 of them. And they tell a similar story, one that we've seen so far. It tells us that we use our energy at night. This has always been the narrative. We use our energy at night, hence solar energy cannot work for us. Well, the fascinating thing is, if you look closer, that narrative changes. If you look a bit closer, that narrative turns into 3 stories. Look even closer in a splash of color, and we see 5 stories. It turns out energy works differently in each of our homes. So there is a chance for solar energy to work for us and not be so wasteful. So the question is, can we take these changes we see here, these differences in how people use energy, can we use that to help people use energy better within their homes? To answer that question, I built an algorithm, one that tries to learn everything about you and how you use energy within your homes. Now, it does this by finding trends and patterns and correlations within your energy data and uses that to improve how your home uses energy. Now, I wrote this algorithm and tested it on a virtual home in Arizona, and it worked. Okay, it worked, but it was awful. In fact, the home ended up wasting more clean energy than we thought was humanly possible. But here's the thing. Just like a baby learning how to walk, the algorithm soon started to pick up on the energy habits of the people living within the home. And once it got the hang of it, it started to do some truly amazing things. You see, the algorithm started to figure out the energy demands of the home. It also linked that with the weather forecast. And using these two, it was able to figure out the best times to generate and use solar energy within the home. Moreover, it started to intelligently store some of this energy for use at night. And it knew exactly how much to save by predicting how much activity is going to happen in the home that evening. Even better, it started to make money. See, it monitored the energy price and it sold any excess electricity we had back onto the energy grid. But it only did it when the energy price went up so we can make a profit. This is just a snapshot of some of the things we're able to do with clean energy, using nothing new, no new technology, just your own innate energy habits to help solar energy work better for us. But this is only the beginning. Just like an Uber and Airbnb, I also believe in the idea of sharing. Now, the current future we are looking at a future where every home would have a solar panel on its roof. But the future I envision is one where our homes can share these resources. And our algorithm is already taking huge strides towards making this happen. It's today allowing us to pair homes based on their complementary energy habits to allow them to use solar energy together and share these resources. Let's take a minute to imagine the implications of such a capability, especially in low-income areas where not everyone can afford to have a solar panel on their roofs. This is the clean energy future I'm building, one which merges the idea of artificial intelligence with clean energy ideas, one that harnesses your own innate energy habits to help solar energy work much more cleaner and waste a lot less energy. Clean energy today is extremely wasteful, but it doesn't have to be this way. Through research like mine, we're taking huge strides towards making solar energy work best for us, because the consequence of doing nothing is a story none of us here can rewrite. Thank you so much.
Thank you, Phil. Any questions from our judges? We have a mic coming down.
Hi, that was great.
Thank you.
I'm Antonina with the Western New York Environmental Alliance. I have a question about capturing this data at the household level and what kind of infrastructure is needed within that household to be able to do that sensing or monitoring.
Yeah, great question. So currently what we're capturing is your meter data. We're also dealing with homes which have smart meters on pretty much every equipment in the house. So what we have right now, we're looking at things from your washing machine to your lighting. They all have these little sensors on them. But this is when we're looking at a smart home. But then most homes obviously don't have this. So what we're looking at is just the raw sensor data, the raw meter data. And it turns out you can actually, just looking at the raw meter data, you can still extract different signatures which align themselves with like the TV. So we can still learn all these things using just raw meter data. But the cool thing is, if you look at third world countries, for example, which is one of the places we'll love this to go to, you don't have that data. So that's one of the roadblocks. We're trying to figure out ways to be able to bring such a technology in places where basically there is no data. How can the algorithm adapt to something like that?
Yeah, so hi, Philip. I'm interested to know more about how you sort of plan transacting this data. You talked a little bit about sort of making money through a revenue sort of system for individual households that could be transacted between different parties. Could you talk a little bit more about that?
Yes. So the current idea is we can have one solar panel and have multiple homes try to use it. And so basically this centralized algorithm basically takes in the energy use of each home. And it basically plays middleman. It looks at how each home uses its energy, and it figures out the best way to divide whatever energy is being generated by the PV panel to these homes. Now, in this sense, there is no monetary transactions happening at all. The money then comes in only when we start selling energy. And the way it would distribute that money, that would have to be decided by the people within this cluster of buildings who are sharing that energy. But the main focus here is just making it available for them to be able to share energy. The money part is nice, but that's not our main focus currently. But to add on to that, there's currently a lot of technology coming up, like blockchains, which are already tackling that money problem, enabling us to take away the energy grid and just have people automatically have revenue flowing between them. So I think that part can be sorted by blockchain. That's not the primary concern of our work.
All right, so that was your 3 minutes. So
Okay.
thank you, Phil. All right.
Thanks.
We're gonna we're gonna have up Kelly Mosher up next and her presentation, Agricultural Community Vitality.
Thanks. You have the clicker. Thanks. Sorry, it took me a second to get up here. Hi, everyone. I was a fourth-generation family farmer, and I'm a first-generation climate warrior. I read an article a little while back with an opening line that said, agriculture, both a cause and a casualty of climate change. This might cause you to think, how is it that both a problem and a solution can exist in the same system? Today, we're going to consider transformative, systems-based approaches to two main issues facing modern agriculture that can simultaneously act as catalysts for climate adaptation. Agricultural production, farmland preservation, and energy production can all coexist simultaneously in the world we want to build. First, agriculture is a multi-trillion-dollar global industry that both directly and indirectly consumes energy. In the United States, the United States Department of Agriculture reports that in 2014, agriculture accounted for 2% of total U.S. energy consumption. Agriculture is also an energy producer through the growth of plants and animals and through processes such as conversion of waste. In the 2014 survey by the USDA as well, it was noted that just 6% of farms participate in energy production processes, and $56,000 is the annual expected revenue generation and payments from these processes. Energy is a primary concern on farms as it is a huge cost to small and medium-sized farmers. The primary size of farmers we have here in New York State, it's where they spend the greatest amount. The second problem is the issue of farmland preservation. The decrease in available land is a burden to agricultural opportunity, an issue that's been ongoing in our country for decades. If you look at the map at New York State, the key areas of our urban areas in New York State along Buffalo, Syracuse, Rochester, towards Albany, and down towards the Hudson River Valley face the greatest pressures from development. There have been years of strategizing to combat this issue, but still available farmland decreases because of external pressures. Our agriculture communities face multifaceted issues and extreme hardship, and we need systems-based approaches that transform these problems into solutions. Sure, you could argue that the idea of the agricultural community is shifting as our world urbanizes, but we will all forever need food. Food that requires quality land and soil to be grown and produced on, and people to care for that production. Family farmers, such as the kids shown here, are stewards of our world's most precious resources, and my focus has been on finding climate-friendly solutions that build vitality for their future. New York State's focus has been on reforming the Energy Vision, or REV for short. The REV initiative is a prospectus for New York State's energy future. REV has some very concrete goals it wants to achieve as a state to reduce our footprint, but there remains a need for industry-specific action. This is one way to do that. We can leverage our farmers, the people who know how to craft and to create from the world's resources. We can be efficient with those resources in ways that ensure future usability and economic scalability. In Michigan, new groundbreaking partnerships are evaluating the effects of solar and wind energy systems on farms for farmer land tenure, farm succession planning, meaning who's going to take over the farm when the next generation comes along, and models for revenue generation and sharing in communities. Here in New York State, our Energy Research Development Authority, or NYSERDA, as we've talked about today, is assisting with renewable energy infrastructure systems on not prime farmland or those areas where agriculture is not viable to guarantee that conservation of land is a key proponent of our local policies. We want to put renewables where they make sense and have the greatest impact on our communities. Facilitating connections between revenue streams, land development, can excel the New York State REV initiatives and continue to support a thriving agricultural industry that protects the amount and use of our resources. We have a great asset in our farmers. and they know how to care for the land, they steward the land, and they ultimately understand the inherent value of the land. I take inspiration from my grandfather, who I'm sure said this more than once in his 60-plus year tenure as a farmer. I own the cows, so I can afford the land. A true love of land management that earned him Conservation Farmer of the Year by the Western New York District more than once in his farming tenure. New York State's agricultural communities must be a central focus in the decision-making for our energy future, because not only are these communities stewards of the resources for the world that we have, that we require, and that we value, but there's a growing need for more conscious generation and use of these resources overall. Agriculture fosters community and innovative thinking, and it can be a platform for individuals of multiple backgrounds to engage in collective practice, which is something that is embodied within the REV legislation. A mentor once said to me, if we can be on the upside of a down situation, why not take the opportunity? No one wants to find themselves with a decreasing share in a market that is ever more necessary. I urge you all to consider renewable energy as our opportunity and farmland as our market. Active preservation through innovative action can increase vitality in our ever necessary agricultural communities. Thank you.
Thank you, Kelly. Wait, hold on. Yeah, we got some questions.
You've got plenty of questions for me, I'm sure.
Kelly, thank you. I have a question about a way, sort of a concrete idea you might have about moving this work forward in the region. What would be sort of a short-term activity of other policymakers or NGOs or government to move this work forward that you're proposing?
So because of my planning related background, I'm going to give you a policy answer to that question. And it's not necessarily short term, but it could be short or long term. So because we have the REV legislation in New York State, that's a state level policy saying renewable energy and a prospectus for our energy future is important at a state level. And very few local governments have something similar that supports the REV initiative or reinforces the REV initiative at a local government level. So looking at ways that we can incorporate agriculture into our policy making related to renewable energy and our energy future at a local government level is really key. And one way to do that would be for a local government or even New York State to say, to write agriculture right into the legislation and to say that any land that is viable for farming or has conservation value could be put under a permanent conservation easement held by the local government legislative body, and at least 80% of that land has to be viable for farmland or conservation use, and the remaining 20% could be used or should be used for a renewable energy infrastructure project, with the idea being that once that energy project, the infrastructure outlives its potential 10 or 20-year life, and we get to a point in our community where we are in need of more locally grown food or agricultural products, that land has less of a conversion value back to usable farmland.
Quick follow-up,
Yeah.
Kelly. How do you see that interplaying with the general sort of deference to municipal governance over land use?
Can you be a little bit more specific? Like municipal government not wanting to touch land use to a certain degree, or?
If I understood your idea correctly, it was to sort of have some statewide framework for the utilization and conservation of land that combine renewables and agriculture. And I guess I'm questioning how do you see that sort of playing out with the general deference at the state level to have municipal governments control land use?
Sure. So I think it actually could be an opportunity for the local government level to step up and say, The state is telling us it's up to us to make a decision about how we're going to use our land and what we're going to set aside land for. And local governments could then act collectively or act individually as champions for legislation to put legislation such as this in place and then act as models for other parts of the country. I do know from work with a few of my mentors I've had that there is legislation in play similar to this in other areas of the country at the state level, but that works because their state level government is kind of the be-all, end-all governing body, and the deference is towards state government, not local governments. Okay. Thanks, sorry.
Next up, we have our first non-UB team from Rochester. So this is Dmitry Eliapich and Ambient PV.
Okay. Well, greeting everyone. My name is Dmitry Eliapich. I'm from the Rochester Institute of Technology, and it is an honor to give this presentation the day after Earth Day. Because after all, billions of batteries end up in the landfill each year. And I mean, many of these batteries do end up getting recycled, but it still takes a lot of energy to manufacture those batteries, not to mention recharge them. And it takes a lot of energy to manufacture them and recharge them, and if statistically speaking, if your energy is coming from the US, it's going to be from burning fossil fuels. And fossil fuels contribute to the emission of greenhouse gases. But even if we were to use emission-free energy to charge and manufacture batteries, we still have to recharge them once the batteries die. Not to mention get rid of their battery waste. And just think about all the wireless electronics that we have. Why do we need batteries when we can be using energy harvesters to supplement the energy in our battery? Energy harvesters like photovoltaics, and photovoltaics like solar panels, which generate energy from the light, photons, and convert to electricity, volts. But what happens when you take a solar panel and you bring it indoors? There's still plenty of light in here, but solar panels were never designed to work indoors. They're designed to work off of direct solar radiation. Good luck trying to charge a battery with a solar panel indoors without any direct solar radiation. So our team from the Rochester Institute of Technology took action to solve this issue, which led us to develop Ambient PV, your indoor photovoltaic solution. Ambient PV was designed from the start to take advantage of indoor lighting from fluorescent and LED lights to extend the battery life of your electronics or power them directly. We also have the ability to print our material and customize its shape to maximize energy collection, unlike most solar cells, which are on a rigid glass structure. So just think about all the wireless electronics that we have that are currently being used for batteries. Like this clicker, for example. If this was powered with ambient PV, it could be trickle charging throughout the entire time and, decreasing the chances of it failing during a professional presentation. What about your cell phone? Imagine if your cell phone was covered with ambient PV. It could be trickle charging and extending your battery life, and if you're indoors, it might even be able to boost your signal, which is great. Or what if you never had to charge your remote controller anymore because it'd be powered by the light that's in the room while it's hanging out and you're not watching TV? And now that LED TVs are out, you may actually be able to charge your remote controller from the light that's coming from your TV. That'd be pretty cool. The Internet of Things is a booming industry. It's expecting to deploy over 50 billion IoT devices by 2020. So you can imagine how many batteries are going to have to be installed in order to service these wireless IoT devices. Moreover, industrial IoT requires a 10-year minimum battery life, and most batteries only last 4 to 8 years. So ambient PV has the ability to extend that lifespan past that 10-year requirement, enabling industrial IoT, which are like sensors that are looking at the efficiency of a factory. And so we have the ability to get those sensors in the factories to make them more efficient by having the batteries last longer than 10 years, which, given the trajectory of the IoT industry, this would be great for the industrial IoT to be able to take advantage of the multi-trillion-dollar expanding IoT industry. And some companies are already using energy harvesters in their electronics to be able to extend their battery life, such as this flashometer application. You may recognize these in public restrooms, like in a university or an airport, and whether they're on a urinal or a toilet, they flush automatically. What you may not know is that these actually require batteries to power, and that when the batteries die, somebody has to go in and change them. So this is where ambient PV becomes a unique solution, because ambient PV not only performs 3 to 5 times better than silicon solar cells indoors, but we have the ability to print the whole exterior to therefore provide enough energy to power the unit whenever it's needed. So you no longer need batteries to power the device, as long as you're not peeing in the dark. So ambient PV reduces the need for batteries by reusing the ambient light around us using our recyclable photovoltaics. And we believe that the future of wireless electronics won't have to rely on batteries for power, because they'll be able to power themselves using innovative energy harvesting technology like ambient PV. Thank you.
All right, thank you, Dimitri. Any questions from our judges? Danita?
Thanks, Dimitri. That was great.
Thank you.
I want to ask a question about this sort of longevity, and you talked about the 10 years that batteries should last. So iPhones come out, new iPhone comes out much faster than in a 10-year span. So I wonder how your proposed technology or your built technology deals with the constant change in electronics innovation and the speed with which that happens.
That's great, and I appreciate you bringing that that question, because I haven't been asked that one before. So the cool thing about ambient PV is our technology is actually fundamentally different than most photovoltaics, so we have the ability to recycle it. And so if your iPhone dies in 3 years, but it still has a functioning PV unit, they can just detach it and send it to be recycled, or even be reused into another electronic. You're right, because most electronics are not intended to last more than 5-6 years, right? Product obsolescence. But there are critical applications that require the batteries to be longer. So that's why the IoT industry is really attractive, and industrial IoT in particular, because that's where the demand is going, and that's where they need to have that longer battery life. And for something like your cell phone, it has a really large battery capacity, so it will allow it to extend the battery life, but likely not be able to eliminate the need for a battery for a cell phone. But things that use small units of power, no problem. Thank you.
Questions? Great. Thank you very much.
Oh, great. Thank you.
All right, next up is Hamid Kapoor and his novel design for a wind turbine blade.
See it here. So, is it going to start? Hi, everybody. I'm Hamid, a mechanical engineering PhD student coming from Tehran, a city with 15 million people population. So born and raised in that city, I saw how the pollutant changed the color, sky color from blue into a gray one, and making lots of, troubles for people, especially for elder people and also children's. But this is some part of the environmental issues that we are dealing with currently. On the other side, we know that we have limited resources, that we are responsible for that, and we need to preserve some part of that for our next generations. For me, as a technical person, as an engineer, the answer for these problems are summarized in 2 words: clean and sustainable energy. That has different types, including biofuels, geothermal, hydroelectricity, solar panels, and wind energy. Out of which, as a mechanical engineer, I'm interested in windmills. Because of having lots of, moving components, I felt that there's enough, lots of opportunity in this field for me to be innovative and a helpful person for my society. So the wind energy has positive and negative side. It is the largest new energy as of 2017. It is avoiding emission lots of CO2 and also saving water consumption. approximately 300 gallons per person during the 2017 in the US. And it's creating jobs. But it has negative side. It needs to be cost competitive with other resources. It has transportation issues. Just right now, based on the news, we have transportation issues from Hamburg to the Arkwright. And also, some people don't like it. They say, not in my backyard. So we thought that how we can, tackle these issues. So we thought about an innovative design for wind turbine blade. If you look at the wind turbine blade cross section, it is twisted. It's not straight. This twist is to increase its aerodynamic efficiency. The twist is, however, optimal just for one wind speed, while we know that the wind speed changes, okay, constantly. So we thought that what if we have a blade that is, adjusting its twist as the wind speed changes? It seems cool, right? Like a giant robot that is twisting its arms. It is cool, but it is so challenging for engineers and designers. You need to have special specifications in your, structure that could be easily twisted to minimize actuation energy, while it needs to keep its aerodynamic shape, okay? So to target these issues, we thought about an state-of-the-art manufacturing technique to reach out this smart structure. And that is where additive manufacturing comes together with our design for the wind turbine blade. It has lots of advantages. It is capable of creating complicated geometries, and also it has directional properties that we are looking for. However, additive manufacturing is not yet evolved enough to create 80-meter long blades. But we can use still its advantages by modifying our design. So we came up with this using additive manufacturing. We came up with a design, and we think that eventually we would be able to build our blades on the installation side. That'd be great. The shipment problem would be solved totally. We would be able to customize our blades based on the installation side, while the current ones are not. And we will be able to have recyclable blades, okay? But as I said, we need to modify our design. So we came up with this design, a modular blade including central spar and 3D printed segments that are mounting on this blade and being covered by non-structural skin. So we believe that this blade will increase the efficiency and will allow the turbines to work in lower wind speed, and as a result to bring the electricity into low wind rural areas. It will also resolve some part of the transportation issue and will help us to also to drop the cost. To approach such a blade is a multidisciplinary work. It needs to work on the aerodynamic design of the blade, it needs structural design and control, and also it needs to be manufactured. There's no point if it design a great and optimal blade that has highest possible efficiency, but it couldn't be manufactured. So all of these are interrelated to each other. They are imposing restrictions on each other. So we need to study every single of these aspects. We start our study with aerodynamic analysis. Our case study on a 13-meter blade showed we can increase the efficiency by up to 13%. But this is not the end of the story. Flexible blades carrying the less load, they can reduce the fatigue loads by more than 70%. And by that reason, we can install larger blades on our wind turbines, and as a result, create more electricity by up to 11% more than the regular ones. Also, our structural simulation showed that our suggested design is capable of creating the required optimal shape as the wind speed changes. We have also worked on the control framework, how to change and adjust the twist as the wind speed is changing. Currently, we have a group of 4 students, including 2 PhD and 2 master's students, and in some part, we are working on saving material by distributing the material more optimally inside of the structure. And on the other side, we are testing additively manufactured carbon fiber samples to simulate their behavior more realistically. We believe this project will not only affect the wind energy, but also it will help us to save material and resources in other other components that will be, manufactured by additive manufacturing by distributing the materials more wisely. Thank you. And I need to say thank you for the UB sustainability.
All right, thank you. Any questions from our judges?
Okay, I'm just gonna formulate it quickly. So you laid out a few objectives, challenges. I think you actually had 6 in that slide, 6 different objectives that your design might, 6 different challenges that wind turbines face or the industry faces. I'm curious. There was a slide that had 6 sort of points all the way about the challenges that you started.
Okay.
Yeah. So you talked about like that bottom right corner there, the NIMBYs, right? Who are concerned
Yeah.
about things like sound and what it looks like and it's on my property. What does your design do to address that?
We haven't yet focused on the design, but we hope that at least regarding the efficiency-wise, if the cost drop, we believe some part of those people will like wind energy. And the other thing is that this color, this right side, they are not actually challenged. They're the green side, they're positive sides. And the red part is kind of, negative side.
Got it. Thank you.
Yeah, sure.
Hi. Thank you for your presentation. A quick question, sort of related question, I suppose, is that a lot of the future of wind development, at least in the Northeast, will be offshore in a corridor that sort of runs along the sort of mid-Atlantic up until about the Boston area. Do you see application for this? I know you talked about low wind speeds, but have you thought about sort of higher wind velocity speeds? Some of the transportation issues in particular present real big problems for your traditional windmill blades and all that jazz. So I'm just thinking about application in varying wind speeds and sort of other installation areas.
Okay, by low wind speed, I mean that increased efficiency will allow us to use low wind speed as well.
Sure.
But we are working on all, possible aspects, especially the large ones. And there's some other details that, because of the limitation in the time, I couldn't bring it out. But we are going to work on the vibration of.
So just a quick, so maybe to point the question a little bit, do you think that in a higher wind speed, let's say, for example, off the coast of Long Island, for example, where a very large wind installation is being planned for by New York State, this, the rearticulation of the wind blade would increase the efficiency of large windmill installations as well? Or I'm thinking about, I guess my question is, does this innovation amplify the existing efficiencies of other large wind blades as well, as opposed to just simply creating space for?
Yes, it does, and that's the point that increasing efficiency is not so much high because they are going close to being mature. Okay, they're pre-developed, But in those large turbines, besides the efficiency, even more important than that is the fatigue loading. And the flexible blade is capable of reducing the fatigue loading up to 70%. Okay? And that's another thing. It's called in the renewable wind energy, it's called region 3, where we have more than we need. So on that case, we are trying to stop turbining efficiency. We are trying to keep it, not to produce more than we require. And that's the place that the loading is important. And we are working just right now by keeping the same power, reduce the loading.
Yeah, how you doing? Just real quick, adding on a little bit to Eric's question. Wind turbines have a lot of moving parts to begin with. The type of design you have is very interesting, but I'm wondering if you could speak a little bit about how you balance the efficiencies gained with reliability issues that may come into play with the additional moving parts, especially given that some of them may be located, difficult places to service offshore, that type of thing.
Okay, that's a great question. So this design is both, good points, and the other thing, I'm not going to say negative points, but some points that you need to think about it. So the good point is that by this modular design, if there's any erosion or whatever, the maintenance would be, less time consuming and easier by just changing that module, okay? But on the other side, you're right, we need to, see how much, energy it's required. and how it is behaving against the fatigue. And that's why it's going on just right now on our test. We are trying to find additively manufactured carbon fiber components. Okay, there's not enough data outside for these kind of materials yet. And for that purpose, we have bought a great printer that is using continuous fibers. It's just one type in the industry that is using that. So there's no data on that. And we are trying to see how these materials are behaving, so we can simulate exactly what's going on regarding the deformation, required torque, and also fatigue loading.
So for the point of you haven't done a wear and tear study on any of the material pieces yet, on the moving parts yet, right?
We haven't done the detailed design. We have done kind of framework till now. So I said it's really broad work. So we started our design exploration from aerodynamic going downward.
One more follow-up question.
Mhm.
Have you modeled any production? Have you run production models on any of the ideas? Let's say, for example, a NIMBY spot, let's say in Allegheny County.
Okay.
Hypothetical.
Not on this size. Till now we have had 2 case studies, because wind turbines, you need to have reliable data for them so you can get reliable answers. On the National Renewable Energy Lab, database, there were several blades, so we are picking from those kinds that they have been validated, so you're sure that your results are valid. And we started from a small blade, and we are increasing the size. I mentioned the 13-meter blades, but the next step would be 1.5 megawatt wind turbine that needs, to prepare the files for that. And
Thank you very much. All right, thank you, Ahmed.
Sure.
All right, so we are at our last team. So these 7-minute pitches go by really quick. So let's welcome from Syracuse University, Christine and Deng, and their presentation, The Freshwater Crisis and Clean Energy.
Oh, okay. Okay, great. Okay. Okay. Hi, everyone. We are thrilled to be here today to be able to talk to you guys about clean energy and how it relates to the current global impending crisis of clean fresh water. My name is Christina Fluman, and this is my partner, Kingri Deng, and we are first-year graduate students in the architecture program at Syracuse University. So this semester, we had the opportunity to look into regions of the world that are at high risk of climate change, and we were tasked with the objective to create an installation that not only performed aesthetically, but also performed in a way that it could transform the area and actually mitigate certain effects of global climate change, depending on the region that we were investigating.
The region of the world that we focus on is located in the Southeast Asia, an area expected to destroyed by rising sea level and temperature within the next 100 years. Jakarta is the capital city, which is dealing with some challenges, such as rising sea levels and shortage of clean water and a large scale of urbanization and a rapid change. And there are 4 challenges Jakarta are facing. The first challenge is the saltwater intrusion. Saltwater intrusion has become a major issue due to the rising level. And the second challenge is the garbage accumulation. Due to a serious lack of the garbage disposal service, there has been a large accumulation in waste disposal, and their disposal. And so the third challenge is the
It's the privatization of water and the fact that the government isn't able to provide the basic human right of fresh, clean water to all of its citizens. It's actually only 30% of the population that has access to fresh, clean water.
And the final challenge is the groundwater pumping. This action is actually the fraction causing the city to sink, and so that the groundwater will become decreasing due to the extraction of the water.
Right, so now that we've given you a little bit of background on the issues that are surrounding Jakarta currently, we wanted to help you visualize the numbers and actually show statistically what's going on in this area. So 65% of the population relies on groundwater wells for their access to fresh, clean water. This is because, as I mentioned before, the city can only provide 30% of the population with fresh, clean water. And going along with this, 96% of the rivers in Jakarta are in fact polluted, and 13 of them have been found to contain dangerous levels of chemicals. 97% of Jakarta is covered with concrete and asphalt, so the aquifers are unable to be replenished through rainwater. And lastly, it is projected that this area will have to deal with between 3 to 7 meters of sea level rise within the next 100 years, and this is equivalent to around 10 to 23 feet. So it's clear that the government of Jakarta is not able to provide water to its citizens, and this is due to the privatizations of the system. So actually in 2015 it was decided that they would transfer from the private to the public. So with that being said, this actually provided us with an opportunity to speculate on ways that we could possibly help with getting fresh water to the citizens of Jakarta. And that's where our project comes in, and we call it the Fresh Water Pod. And actually it performs by turning salt water into fresh water through the use of solar radiation. It harnesses natural solar radiation as well as transforming this into energy.
There are advantages and disadvantages associated with any systems. In the case of the desalination, there is the issue of brine build-up, size, and energy required of the system, as well as the harmful effects on marine life. It is a well-known fact that there is more salt water than fresh water on Earth. 97.5% of the world water on Earth is salt water, so why not try to use this salt water? And desalination can be combined with the water filtration so that it can create an even more efficient process. And so how does it work? This destination process works by distilling the seawater and then capturing the fresh water through condensation, and water vapor can be condensed along the sides of the evaporation chamber and then rain down into the collection trough and become available to citizens.
So the bottom of the freshwater pod is actually perforated to allow for a constant flow of salt water into the system. The system is supported by a buoy system that actually keeps the top half above the seawater at all times so that solar energy can always be entering the system. And if there isn't enough of natural solar radiation to provide for an optimum temperature for the evaporation of water, then the stored solar radiation in the solar panels actually brings the temperature up so that water can then be evaporated and condensed along the sides. So once the freshwater chamber is full, the sensors send a message to shore, and these pods are then pulled into shore, and then the public has direct access through a pump that is connected into the chamber. And then the last thing that's associated with this is that there's a light, and it indicates water quality in that area, and depending on the color of the light, depends on whether or not there might need to be another level for filtration before this water can be safely consumed by the citizens of Jakarta. So as designers, we are asked to always be critical of our work as well as other people's work and how it can be adapted to better perform in certain areas. And keeping this in mind, we have speculated on different adaptive abilities such as garbage collection, further filtration systems, larger scale of desalination, and also finding ways to be more interactive with the community and provide better services for the people of Jakarta. And in conclusion, we just want to leave you with a certain mindset that we bring into our work every day. And that is to always be critical and speculative on current issues and to ask questions to get immediate answers, but then take those answers and investigate them and be critical and reformulate your questions to come up with new answers and new innovative ways of addressing different global issues. So thank you.
All right, thank you, team. Speaking of questions, any from the judges?
I was just saying it's interesting to be in the region where we have 20% of the world's fresh water right at our shores. So this is really a challenging problem, even in terms of that community engagement around this topic, right, globally. So I have a question. You talked about desalination and some of the issues when you talked about challenges, and you talked about some of the environmental impacts of desal and the fact that we have so much salt water in the world, so why not? My understanding of desalination, and one of the challenges, or the biggest challenge to it, is the cost of doing it. So does your design and your project in any way address the cost of desal?
So a lot of times when we think about desalination, we think about the really large desalination plants that require a ton of energy, whether it be distillation or reverse osmosis. So the way that we try and mitigate that is that we actually bring it on a much smaller scale. So the size of these would actually only be about 5 by 5 by 5. And in terms, it reduces the amount of energy required for the system and also the impacts on the environment directly, because another thing associated with desalination is the production of brine water, and like what do you do with that? And in our case, because the system is an open system and water is constantly flowing in and out, the solute is moving from a high concentration to a low concentration, so it's constantly cleaning the system. Mm-hmm.
So, hi guys, thanks for your presentation. Really appreciated it. It seems like there's a need for a central collection and distribution system, and that would require some either participation from a government or a large infusion of cash to create that. Have you thought about the implications for that collection and distribution system in terms of the impact that it could have?
Right. So the way that we actually designed this is so that you wouldn't need a large collection and distribution center, because each pod functions, I mean, it functions as a whole, but it also functions individually. So once one is full, one comes, and then it's like this constant back and forth exchanging. And so it's the system we picked for, it's on this slide. So we have 4 different locations for the systems, but actually, that's actually a very interesting question, because the scale of this project, we were only asked to look at, like, it wasn't like a large-scale urban project, it was a very like localized project, but in terms of further community impact, like, we would love to look at it more of an urban project and how we can make a bigger community impact by creating a central center that could also act as like a hub for like community outreach and stuff like that. But you're right, it would require a large amount of capital to even create. So yeah, we haven't really looked into that, to answer your question.
Fair enough.
Thank you.
All right. Oh, wait.
One more. So there are other evaporative models for desalination out there, and I was just wondering how you distinguish yourself from. And I really appreciated the explanation you gave. Sorry, I'll slow down. I really appreciated the explanation you gave to Antonina about how you deal with the brine issue.
Mm-hmm.
But I was wondering how else you distinguish yourselves from the other evaporative models that are kind of being talked about now for desalination.
So I think that the fact that ours they're single units, and also the idea that water is constantly moving in and out. It's never trapped. It's always an open system. And also, we were asked to have an aesthetic quality to it, and the light on top would actually be sort of a performative aspect of the installation.
All right, great. Thank you, guys.
Thank you.
All right, so that was some pretty inspiring stuff. We saw new technologies, new policy work, all tasked to reforming our energy systems, right? So now there is still some food in the back, but I needed to steal the judges. We're going to go through that back door there, and they're going to deliberate. And then in about 10 minutes, we'll announce the winners. So help yourself to more food, and we'll be right back. All right, everybody. If we could all take our seats. So that was a pretty spirited debate back there, and that just goes to the quality of the presentations that we saw. So everybody did fantastic. I will start with the project that was awarded the prize for the societal impact, and that is going to go to Kelly Mosier for her agricultural vitality. Come on up. So we're really excited about the implications of rural land. Thanks. Yeah.
Grip and grin.
All right. So for third place, just want to make sure you're doing it the right way. All right. So for third place, I'd like to award this prize to Hamid Kapoor with his novel design for a windmill turbine. Come on up.
We don't want an Oscars moment, so judges, if for some reason we don't have what we talked about.
Congratulations. Thank you. Yeah.
Congratulations.
Thank
sir.
you. Quick
Good
picture
job.
with this.
All right. Thank you. Congratulations.
This, you cannot cash this, no. Oh, you can have it, yeah. All right, so for second place, we have one of our out-of-town guests, Dmitry Lyapich. So come on up.
It almost pained me to give it to someone from RIT with an RIT tie on.
Congratulations.
Thank you so much.
Appreciate it. All right, now for first place, with a pretty unanimous decision here, so congrats to this person, Philip Ondakor. Please, come on up. All right, so thank you everybody for the presentations. Just so you are aware, we'll probably be doing this again next year. So if you're inspired tonight, or if you want to try again, be on the lookout next Sustainability Month in Buffalo. The sun is still shining, so I think we all deserve to go outside now. So again, grab some food on the way out, and I appreciate your time, and to all the participants, thank you.